All right, 5.3, graphs of relations and functions. Review. If it's a relation, what does it have to look like? Raise your hand. Taylor?
X, Y.
An ordered pair, X and Y. For it to be a function, what's the rule there? Someone raise their hand. Aiden?
It has to be, there can be multiple, yes.
Okay, so no repeating X. No repeating X. Okay, good job. So a relation has to be just an X and a Y. And a function is a relation, by the way, but it cannot have any repeating X's. All right. Today we're doing graphs of relations and functions. Yesterday y'all pretty much just looked at ordered pairs and stuff like that. Today it's going to be a little bit different. You're going to look at a graph and everything and determine whether it's a function or not. One way of doing that is the vertical line test. The vertical line test can be used on the graph of a relation to determine whether it's a function. Now, I'm going to let y'all keep writing. What's interesting about this is some kids are going to get it and some are going to struggle with it. It's like they can't wrap their head around this. If you absolutely cannot get it, it's okay. Okay, you don't have to get it, but it's really helpful. All right? And I can show it in multiple ways, but it doesn't matter how many times I show you. Some kids are going to get it and some just won't. And it's okay. So let's pretend I have my Cartesian plane here. Here's my X and here's my Y. So this is my Cartesian plane. Let's say, and I'm going to do this in red, I'm going to graph something here's my graph. Okay, so there's my graph. The Cartesian plane is not my graph. but the actual graph is in red. So you need to put this down as close to resembling mine as possible. Make sure everyone's got it. Okay, so looking at this, is this, just by looking at it, is it, let's say the book says, is this a function? Okay? You can do what's called a vertical line test. You take your pencil or whatever and just draw a vertical line anywhere on your graph. We're looking at the red, your actual graph, okay? If you can draw a vertical line anywhere on your graph, let's say here, or here, or here, is that line I just drew, is it crossing my graph in more than one place? Therefore, it is not a function. And I'm going to explain that to you. It is not a function. Vertical line crosses graph in more than one place. It is not a function. If the vertical line that I just drew can cross the graph in more than one place. Now, where students get confused is they'll consider the Cartesian plane as their graph. If I say, Michael, how many places did my vertical line cross my graph? How many places? Like 1, 2, 3, 4. How many times does this line cross my graph? Bingo. Here and here. I'll have students say 3 times. Here, here, and here. No, this is not your graph. That is your Cartesian plane. This, the red part, that's your graph. So my vertical line crossed my graph in 2 places, therefore it is not a function. Does that make sense? Cecilia, do you understand? Are you sure? Emily? Gabby? Okay, so notice it crossed here and here, here and here. So no matter where I drew my line, it's always crossing it more than one place. So therefore, it is not a function. Now, there's other ways of looking at it. You can look and say, okay, this dot right here that's on my graph, that is 1, x is 1. I can put that here. And then y is 1. Look at this one right here. X is 1 and the y is -1. We have repeating x's, therefore this is not a graph. But sometimes they're not going to give you the little dots and everything. You're going to have to be able to look at it and say, yeah, this line crosses at the same x point as the other one. Therefore, it's not a function because you can't have repeating x's. Vertical line test is nice because you don't have to get into that much detail. Okay? All right, let me show you another one. What if I do Here's a Cartesian plane again. I'll give you a second to draw it. Now, when you're doing your homework, you are not going to write in a bunch of these things. You're going to use each line of the graph paper. But for, notes, we're doing it this way. Okay, so draw your Cartesian plane. Taylor, are you drawing it? Okay, good. All right. What about there? Okay. Let's say this time my graph, remember this is my Cartesian plane, this time my graph is going this way. So my graph is the red line. Emily, let's do the vertical line test. I can draw a line, vertical line, anywhere on this graph. Here. Emily, how many places did it cross over my graph? That's right, one place. That's my graph. This is the Cartesian plane. It does not count. How about if I do it over here, Emily? How about if I do it right here? How about if I do it right here? That's right. So is this a function? If it can only cross one time, then it is a function. Is a function. Vertical line crosses graph in one place. Up here, this was more than one place. Here, it's just one place. So do we understand the difference? So anytime it crosses the graph in more than one place, it is not a function. Any questions? All right. Whoops. Let's do another example. Does everyone have this? All right. What if there is a set of ordered pairs? Another name would be a relation. Write that down. Cecilia, just by looking at this, is that a function?
No,
Why?
the two repeats itself.
The 2, which is an x, repeats itself. Very good. So it is not a function. And remember, if the y repeats itself, it's 5. Okay, I want to show y'all real quickly another example. on how to write something. Let's say they gave us a set and we had a -2 and 4 and a 2 and a 3. If I were to ask for the domain, and what's the domain again? Raise your hand. Wit?
X.
X. So if this is my X and that's my domain, notice it's the same number. You can't, one's negative, one's positive, but it's 2. You can write that as plus minus 2.
You can?
Yeah. Now, my students try writing this in their homework and it starts messing them up. Okay? Especially when you have to start putting them in order from least to greatest and other stuff. But it can be written like that, and you may see sometimes where they have a plus minus 2. You need to know that that means -2 and +2. Do y'all understand that? And then again, what's your range? That's your Y, correct? And what would the range be, Aiden?
It would be 4 and 3, or 3 and 4.
3 and 4. Because we want to try to keep it in least to greatest order. Now, if there were more ordered pairs and you had something in between, like a -1 or something like that, or a 0, probably wouldn't want to do the plus minus 2 because then you're taking it out of order. So, it can be used sometimes, but not real often. All right, everyone got this? Michael, you got it? Okay. An equation is often used to clearly define the values of the range, which is Y, with each domain, which is X. An equation is often used to clearly define the values of the range Y with each domain X. Blah, blah, blah. We're going to do substitution. Whoops. Substitution. Once you have that written down, put your pencils down so I know you're done. And Emily, when we're done with this, I think there's a bag downstairs for you. Apparently your mom dropped it off. Oh, you already got it? Okay, good. All right, here we go. Example. Now you need to write this down just like I have it written, nice and neat, so that I can explain it, because you're going to see stuff like this and you're going to be like, I don't even know what to do here. Say A equals big old fancy bracket X, Y, straight line, Y equals X plus 2, semicolon, X equals 1, 2, 3, 4, end of big bracket. So write it down exactly like I have it.
You're right, that is confusing.
Right. You're sitting there going, what the heck is this? I'm about to show you. These are what, again, put your hand down, please. Again, I know teachers that will tell students, just use the book. They've got examples. They'll explain everything to you. Right. Guys, here's your equation. That is your equation. You're going to make a table. You're going to put the equation right here. And then right here, you're going to find your X and Y. Y'all recognize this kind of table, right?
Yeah.
And this stuff, it says X equals, guess what we're going to do with that?
We're gonna put it.
We're going to put those numbers over here in this column. This right here, don't even worry about it. This line right here, don't even worry about it. They're basically saying, here's your, relation, blah, 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 blah. Find out if this is a function. And so you're looking for ordered pairs, which is right here. We're going to find that. Here's the equation. We're sticking it here. Here, they gave you the X. So I have 1, 2, 3, and 4. And then we just substitute. We substitute the X here for each of these. So here I'd have 1 plus 2.
I remember this.
So then my X is 1, my Y is
3.
3.
see what we're doing here? So then we're just going to keep substituting. Make sure you bring over your X.
This isn't too bad.
No. Now, question. Is this a function? Raise your hand. Gabby?
Yes.
Why?
There's no repeating
That's right. No repeating X's. You could tell that before you even did the table. They gave you all the X's. Are there any repeating here? Nope. You would know right away that was their question. But sometimes the book's going to have you, they're going to give you this and you need to find all the ordered pairs. Well, there they are. So in this case, if all they wanted you to do was find the ordered pairs, you could just box this if you want, or you could list it. Little bracket, 1, 3, 2 and 4, 3 and 5, 4 and 6 in the bracket. That could be your answer. Any questions? All right, once you have all that written down nice and neat, turn to page 196. We're going to get started with some examples. Does everyone have this written down? Cecilia, do you have it? All right, everyone needs to have their book open to page 196. You there, Whit? All right, 196. Let's look at number 1. It says, is the graph relation a function? All right, look at it. It doesn't have, the dots aren't connected, right? But that's still a graph. You can still apply the vertical line test. So in your book, go ahead, draw a vertical line, and then see does it cross the graph in more than one dot or place. Raise your hand if you think you know the answer, Cecilia. Function. So your answer would be yes. Because nowhere on that graph, even though it's just dots, would you cross it in 2 different places. And if you look at one right here, I don't want to show you my answers from last year. I drew the graph. Here are the dots. I went ahead and connected the dots, told my students to, and then draw the vertical lines. And you can see that it only crosses at one place. Do y'all see that? Does anyone not see it? All right. Good job, Cecilia. Look at number 3. Look at number 3. Is there anywhere on that graph that if you did the vertical line test, it would cross it in 2 or more places? So raise your hand if you know the answer. Aiden?
It's not a function.
No. Because if you notice, several of those dots have the exact same X. Do y'all see that? If you're not seeing this, you need to let me know. Okay. 5. Raise your hand. Michaela, thank you for raising your hand. Is number 5 a function?
Yes.
Yes, because no matter where you draw the line, it's going to just cross it one place. Now, guys, some of these are going to be tricky, so be careful. All right, let's look at number 7. It says, for each graph relation, state its domain and range and whether it's a function. So you're going to have 3 answers. So look at 7 and all those dots. They're not connected. That is a relation. It is a graph. They want to know what is your domain. So the one thing I would do is first write out all of your ordered pairs for each dot. So someone give me an ordered pair that goes with one of the dots. Taylor.
0, -1.
0 and -1. Okay, another one. Someone else. Aiden.
-1, 0.
Yes. -1 and 0. All right, another one. Someone else. We're looking at number 7. If you see the dots, figure out the ordered pairs. We have 0, -1, and -1, 0. Someone that hadn't answered? Michael? -1 and -3. Someone else that hasn't answered? I have 3 more dots. Gabby?
-4 and -2.
Yep, -4 and -2. I'm calling on people that haven't answered yet. Emily, do you know one? Negative 3, 1, 2, 3, and negative 1, 2, what? Huh? I didn't hear. Okay, so negative 3 and negative 3. And I think there's one more. Let's see, Cecilia.
Negative 2. I mean, negative 4.
Negative 3 and negative
3.
we already did that. Negative 1. Okay, so list those. Now we can write our domain. So remember, our domain is all the x, and we want to write it in order from least to greatest. So let's see, Michaela, how would I write my x's? And you don't have to do repeaters. So what would come first?
Negative 4.
Negative 4. What'd be next?
Are you supposed to put a little parentheses thing?
No, because we're not doing order pairs, we're just writing the domains.
Okay.
So what would be next?
Negative 3.
All right, and then?
Negative 1.
Okay, then?
0.
Very good. There's one of your answers. See why it's good to put the order pairs down? All right, range. That's going to be your y. Let's see, width. What comes first?
Negative 3.
Uh-huh.
Negative 2.
Uh-huh.
Negative 1.
And?
0.
Okay. Is this a function? Gabby? No, it is not. Why isn't it? Look right here. Here's a repeating x and a repeating x. We have another one here and here. We can't have repeating x's, so it is not a function. Do you understand? All right, let's look at number 9. Same thing. They want to know domain. They want to know range and whether it's a function. So first thing we need to do is list all of the ordered pairs. So start raising your hand and tell me what they are. Width.
Negative 1. Negative 1.
Negative 1 and negative 1.
Oh, wait. Positive 1?
There you go. Negative 1 and positive 1. All right, another one. Gabby. Negative 4 and 1. Another one. Cecilia.
4 and 2.
4 and 2. Another.
4 and 2.
Okay.
2, 2.
Yep. 2 and 2. Another one. Aiden. 0 and 2. Michael.
3.
3 and 1. Is that everything? There should be another.
Mm-hmm.
Which one's missing? Taylor?
1, 1.
1 and 1. Okay, so let's write our domain. Those are your x's. Remember to write them least to greatest. Taylor, what would they be?
Negative 4. Negative 1. 0. 1. 2. 3. 4.
Good. Emily, what are my ranges?
1 and 2.
So we have a lot of repeaters for y. Is this a function?
Yes.
Yes, it is. Because you can have repeating y's, but you can't have repeating x's, and there are no x's repeating. Any question? When you have this written down, please put your pencil down so I know you're done. When you have 9 completed, bless you, put your pencil down. All right, buckle your seatbelt for 11. I need your full attention for 11. Y'all see number 11?
Yes.
Okay. Pay very close attention. The domain, this is how you're going to write it. I'm going to tell you what it is. Look at that crazy graph and look on the x-axis only. Look at the x-axis only. Do you see the furthest place on the x-axis that graph covers? I'm going to show you. Okay, let's zoom in a little bit. All right. Okay. Notice I put dots. The graph stops here at that x, correct? See, the end stops right here. Do y'all see that? Does everyone see that? If you don't, you need to say something. And then this right here stops at this x. Does it go further here or here? Are there arrows right here to say it's going to keep going and going? So the x, the last x here is at -2, right? The last x that it covers here is +2. So therefore, you write it x line -2 is less than or equal to x less than or equal to +2. That is saying that x can be all or any numbers between -2 and 2. So write that down, and I'm going to show you again. Y'all have it written down? Notice the lines connected. That means all between here and here, all of this are a bunch of x's, right? If we were to put a million little dots here, all of those are ordered pairs, correct? They're covering this part of the x-axis, all the numbers in between. So the domain is between this x and this x, -2 and +2. Okay? Range. Well, let's look at it again. Here's your y-axis. All of this, if we were to do a million little dots for ordered pairs, they're covering a whole bunch of the y-axis. So it would be written like this. Y between -4 and +4. Because it doesn't, there's no arrows, so it just goes on and on and on. Is this a function? Draw a vertical line on your graph. Draw a vertical line, not horizontal, vertical.
I don't know which way that
That's up and down. No matter where you draw the vertical line, does it cross the graph in more than one place? It is a function. Because no matter where you draw that vertical line, it does not cross at the same x. Yes, sir.
I think I'm thinking too much into it, but the lines at the top and bottom are going straight down to the point.
You're thinking way too much into it.
Okay.
All right. Let's look at 13. Represent each function as a set of ordered pairs and graph the function. All right, so 13 gives you this. So that's what 13 gives you. Remember, this is your equation.
Ms. Rogers?
Yes.
They're ready for y'all, for the class pictures.
Okay, thank you.